Hi boys and girls, in primary 5, 6 and 7 and second level we're going to stretch a little bit today. We are going to look at chemical reactions. Now, I know what you're thinking explosions, you're thinking fire. It's nothing like that because we need to stay safe and we need to stay in control. Okay, so nothing explosive, but it is chemical reactions. Now, primary 5, 6 and 7, I think you know about some of this already, and I'm hoping you have a knowledge already. So here's what I think. I think if I said to you, what is this and what is this? You would start by telling me, oh, that's vinegar and that's bicarbonate of soda because that's what it says on it. But thinking about the chemicals inside it, what could we describe them as in a scientific way? So, an acid, an alkali, acid and a base. Now, used to call it alkali, still do call it alkali, but also they can call it a base now, and an acid. Now, you've probably seen things on telly where they add the two and you get a reaction, like you get the volcanoes that come over. I know upper school have done a bit of this sometimes, or you get them in a little tube and it pops out, gives a reaction because the two are opposites. An acid and alkali are opposites, so they have a big reaction. It's a chemical reaction. So that's what we're banking on today. If you want, if you have time, if you can get hold of it, try mixing it together. A little bit of this, a little bit of that, see what happens. Now, I'm hoping that you already know that, okay? So what we're going to do today is we're going to look at fruits. Two fruits. We have a lemon and we have an orange. Both of these fruits have an acid inside them. So the orange has ascorbic acid and the lemon has malic acid, otherwise sometimes you might call it citric acid. And we're going to see which of these two fruits is the most acidic. So remember, if I added acid with alkali, we get a reaction. So I'm going to add my base, my alkali, to the lemon and to the orange and see what happens. Which one reacts the most? And the one that reacts the most will be the most acidic. So what you could do at this point is you can try this at home, obviously, but you could comment and say which do you think is going to be the most acidic, so you're predicting. And we're going to add the same amount of base or alkali, add the same amount, we will leave it for a couple of minutes and we'll see which has the biggest reaction. And the one that has the biggest reaction will be the most acidic. That's the plan. So I'm going to pause it there, we'll zoom in a bit closer, you can see what we're doing. And as I say, you can try this at home. If not, just comment on what you see and what you think. So at this point it would be, which one do you think is going to be more acidic? Maybe even tell me why. Okay, so I'll pause you there and we'll get you zoomed in a bit closer so you can see what's going on. Okay, right. So you can hopefully see this closer. We'll get one cut and then the other one cut. So I'm going to take the bottom off of the lemon so that it sits nicely for me. And then I'm going to cut it in half so we can get the juicy insides, and I'll put that to the side. There's our lemon ready to go. Same with the orange, although actually it sits quite well, but I'm going to take the bottom off just so a flat edge. Sits better, and then we'll flip it and cut it in half, making a lovely mess. But that's why I'm doing it on a cutting board. Okay, there we go. Two ready to go. I hope you can see that. Knife to the side. So here we have our base, our alkali, which is now being stubborn and not opening for me. Here we go. Now I'm going to take a spoon of each, a tablespoon of each. So it's a fair test, a level tablespoon of each. Okay. So, tablespoon in the middle and tablespoon in the middle. There we go. So, mix it in, spread it out a bit, spread it out a bit. I'm going to give it time. Now, what you find is, at this point, the acid is locked inside the fruit. So we have to squeeze it a little bit to get the acid out. So if I mix it in, squish it in, look at that. It releases. I'm hoping you can see that reaction. So it's releasing some of the acid out. Now, straight away, I think you can probably see what is happening. So, what do you think is happening here? Take a close look at the two of them. What's the difference? I've done the same with both. Can you see one reacting more than the other? Why do you think that is? Now, what I'll do is I will ask you to send in your ideas and things on Seesaw. I think you can see a difference here. And then what I will do is I will put some answers at the end of the video for you to listen to if you want and compare with what you were thinking. Okay, so I'm going to pause it there and I'll put the answers at the end. Okay, I look forward to seeing what you've got on Seesaw. Bye. Okay, so here's your answers. What you will see is that the orange has reacted. The ascorbic acid has reacted with the base and given you fizzing. It's come over the side. It's got a good reaction to acid and alkali, acid and base. And over here, the lemon has given more of a reaction. Same amount, but more of a reaction. The malic acid inside the lemon has given a bigger reaction, which tells us that the acid here is a stronger acid. It's stronger strength of acid compared to the ascorbic acid. Different types of acid, but it tells you this is stronger. Now, think about the taste. The lemon has a far stronger taste compared to the orange, which is linked to the acid. So the more acidic, the stronger the taste. The less acidic, it's a less strong taste. So you think of a lemon, you squeeze into that, bite into that, very strong taste. Orange, sweeter taste, nicer taste, less acidic. There you go. Now, if you get a chance, try some different fruits at home. I would love to see some different fruits of what you think. That's just two. I'd love to see what you can come up with at home. Okay, bye for now.